Today, I'm going to be working with Abraham, and we are going to try to demonstrate to you guys what makes a square. In math, we commonly hear, phrases like 2 squared, 3 squared, 4 squared, and so on. What does that look like? Well, I'm going to use Abraham to help me demonstrate this. Now, normally I do not use these, but it's what I had at hand, so I'm going to try to make good use of them. Since it's really all I have to use right now, I don't have what I typically use. So let's just go ahead and dive in. So this is Abraham, and there are 3 of them. Abraham is going to serve as my soldiers today that are in my squadron. I'm the commander, and my command to my squadron is to line up in the form of a square. I want them to be in a square formation. So they're attempting to line up in a square formation, and nothing's working. They're unable to get there. So we're actually going to need more soldiers. So let's bring over some more soldiers. Now they are successfully able to line up in the form of a square. So my squadron with 4 soldiers was able to form a square. And I think that's important because what we're going to do, I want to write this down over here to the side for you. 4 was able to work as a square. So I had 4 soldiers that were able to line up in the formation of a square. Well, if we look at this square and examine it more closely, we have a square shape. They were able to line themselves up in a square shape or square formation. Now, across this side, I had 2 soldiers, and across this side, I had 2 soldiers. So we could say I had a 2 by 2. And 2 times 2 equals 4. So those are my 4 soldiers. So over here, I'm going to say, okay, I had a square that was comprised of 4 of my soldiers. Now, what equaled that 4? Well, it was a 2 by 2, or 2 times 2. That was equal to 4. Now, let's come back over here. Now, I have a 5th soldier that arrives. Well, no matter where this soldier lines up, we are not going to be able to form a square. Unless he jumps on the back of another soldier, but I imagine that that would be frowned upon in the armed forces. So we're going to say that the commander wouldn't be too happy with that. So that's going to be against the rules. So we're going to have to stay each individual soldier on their own in their own space. Well, I can keep adding soldiers to my squadron until I get another square. Well, here I do have another square now. I was able to form another square with my soldiers by getting 9 soldiers. So those 9 soldiers were able to form themselves into a square. There are 3 across this way and 3 across this way, or a 3 by 3, which is 9. So my 9 is a square formed from a 3 by 3. Now, if you notice, 3 by 3 is the same as 3 times 3, which is 9, and there are 9 pennies that make up the square. So basically, it's length times width, which is the formula for the area of a square. So this particular square has an area of 9. Now, what do you think the next amount is going to be that I'm going to be able to make a square with? How many soldiers am I going to have total for my next perfect square? Well, can add 3 more there. That's a rectangle. I'll just keep adding some soldiers here until we are able to get a square. I believe we now have another square. So I have a total of 16 soldiers now. These 16 soldiers were able to get in the form of a square. So they line themselves up in the form of a square. I have 4 across this way, and I have 4 across this way, or 4 by 4 square. So I have a total area of 16. So 16 would be my next perfect square I was able to form. 16 would be 4 times 4. Now, let's come back over here. Do you think you know what the next perfect square is going to be? Well, if I keep adding pennies, soldiers, I should say, to this squadron, the next square I'm able to form, it's going to be 25. I have 5 across this way, and I have 5 across this way. 5 times 5 is 25. So I was able to form another square. Now, hopefully by now, you may have realized that if you look over here at this chart, that my squares, I started with 4, then I was able to make a square with 9, a square with 16, and a square with 25. If you look over here, all of these numbers that I'm multiplying with themselves. So I took 2 and multiplied by itself, 3 multiplied by itself, 4 multiplied by itself, and 5 multiplied by itself. Anytime you multiply a number by itself, it results in a perfect square. So 4, 9, 16, and 25 are perfect squares. If you want to know what your next perfect square is, and you're not quite sure, then you notice a pattern here, 2, 3, 4, 5. Well, we can say 6 times itself. 6 times 6 is 36. 7 times itself is 49. All of these are perfect squares. So you can use this to help you determine the next perfect square as you go. So let's say you say, okay, well, what if I did 10 times 10? Well, that results in a perfect square. What do we call this number that multiplies with itself to form a perfect square? Well, this is called the square root. So the number that multiplies with itself is the root of the perfect square. So if we look at 16, 16 is a perfect square. The root is 4. So you only need the number once. So if somebody said, well, 25 is a perfect square. What is its root? The root of 25 would be 5. One other thing I would like to kind of show you is, and this one's a little tricky, that's why I started with 4. Using pennies, it's not always the best thing to do. Now, here we say we have 1 penny. 1 is a perfect square. So I can say, well, my soldier lined up by himself. He was able to line up in a square formation. The penny itself is circular, but the formation is still a square. He was able to line up in a square formation. I can't say that he's not in a square formation. So what we will say is that, I'll come over here and say 1 penny is a perfect square because 1 times 1 equals 1. So the root of 1 is 1. So 1 penny would also be a perfect square. I understand that Abraham Lincoln was a very good storyteller, and he was also, he was into jokes. He liked telling jokes and hearing jokes. So in that spirit, what did the dime say to the penny? I have more sense than you.